Then the next part, electric field due to dipole on equatorial point. Dipole due to or on equatorial point. What is equatorial point? Minus Q plus Q. I want to find the electric field at equatorial line, anywhere on this line. So I am finding my electric field on this point, this one, yeah. So how do you find it? In our last class of electric force, I told you about two type of methods which you can follow when you have a group of charges, right? What were the methods? One was the conventional method of finding the resultant using the vector format, and the other one is by finding the components. This method will be followed by us. Okay, let me draw the diagram first. This is a negative charge, this is a positive charge. So electric field due to particle at A on this point will be vertically inwards, right? And due to particle at B, this is a positive charge. So consider the diagram to be this. The electric field due to particle at B will be vertically outwards, like this. This is EB and this is EA. I want to find the net electric field due to this dipole. What should I do? I'll make the components. Let's say this angle is theta. This angle would also be theta. Angles opposite to equal sides are equal. These are theta. That means before going to components, how would you start this derivation? I told you about the introductory lines. Let's do it again. What will be the introductory lines in this case? Consider a dipole of charge minus q and plus q placed at a distance 2a. That's it. Not much in detail, but not introducing. Alright. So while you start the derivation, what would be the first step? First thing we mentioned was the electric field due to particle at A. So I'll be writing the formula or the magnitude of EA. Why am I not going for direction here? Because I've already represented my direction here. So EA is equal to 1 upon 4 pi epsilon naught. Again, the distance, consider the distance, this perpendicular distance to be r from this point to that point. So 1 upon 4 pi epsilon naught, charge is q, not the minus q because magnitude, upon this distance ka square. What is this distance square? This thing is A, this is R, so this would be under root R square plus A square, right? This distance. And in the formula of electric field, we have KQ upon R square. This R is basically the distance, this particular distance, AP. That would be better if I note it like this, AP square, or 1 upon 4 pi epsilon naught Q upon R square plus A square. Under root got cancelled out. This is the formula for electric field at A, which is equal to the electric field due to particle at B, because in case of B, charge, the magnitude of charge, the distance remains the same. So the same formula. Now, since E and EB are equal, they are in these directions. If I would have known the angle, exact angle, this whole angle between these two electric fields, I could have just taken the resultant and we have got the answer. But now we don't know the angle. So what will I do? We should do this thing. This angle is theta, side opposite to equal angles are also equal. This is also theta. With this theta, this will be the alternate angle, and with this theta, this would be the corresponding angle. Make the components for electric, for this thing EA. I told you where there is theta, there will be cos. So this component would be EA cos of theta, and down it will be EA sin theta, right? Similarly for EB, the horizontal component would be EB cos theta, because this angle is theta, and vertical component would be EB sin theta. Since EA and EB are equal in magnitude, these vertical components gets cancelled out. This is E, don't mistake this. So these vertical components being equal and opposite in direction, they get cancelled out, and you are left with the horizontal component only. So what you have to write is, while after doing this part, what you have to write is the same statement which I just told. Since EA is equal to EB, the horizontal and vertical component cancel out each other, and the net electric field due to dipole is in the horizontal direction only, which is given by EA cos theta plus EB cos of theta. EA is equal to EB, that means I can write EA here. This will give me 2 EA. EA cos theta plus EA cos theta, that is equal to 2 EA cos theta. 2 into, this is the value of EA, 1 upon 4 pi epsilon naught Q upon R square plus A square cos theta. What would be the cos theta? Take any triangle, cos theta is base over hypotenuse. Base is A over the hypotenuse, R square plus A square under root, which is this. Under roots are represented by 1 by 2, cube roots are represented by power 1 by 3, and so on. This is the basic representation. This R square plus A square is raised to power 1, and this is 1 by 2. So ultimately in denominator it will be 1 plus 1 by 2, which is 3 by 2. So over there you are left with 2QA upon 4 pi epsilon naught R square plus A square power 3 upon 2. And this term is the dipole moment. So what is the final answer? Net electric field due to dipole on equatorial point is this, P over 4 pi epsilon naught R square plus A square or 3 upon 2. This is your final answer. Now, special case. This special case is like this. Again, the same thing. What if the distance from the on the equatorial point is much larger than the dipole distance? This being the dipole and vertical distance be too large. So accordingly, special case, write it down. If R is greater than A square can be eliminated or neglected. A square can be neglected. So E would be equal to P over 4 pi epsilon naught. A square is neglected, you are left with R square raised to power 3 by 2. What is this? R square into 3 upon 2, that means R cube. So this becomes P upon 4 pi epsilon naught R cube. This is the formula in case of special case for electric field due to dipole on equatorial point. Do this formula has any similarity with the formula we just derived before? There on axial point, okay, I am writing this equatorial, okay. E on, let me write it with a small e, that will be more clear. Electric field on axial line was, the final answer was 2p upon 4 pi epsilon naught R cube, and on equatorial point it is just p upon 4 pi epsilon naught R cube. So what is the relation? Is electric field on equatorial point is twice the electric field on axial point? Reverse it down. Electric field on axial point is EA twice of electric field on equatorial point. So that concludes the formulas for electric dipole.